All right, we're going to continue on answering the essential question, how are similar polygons related? These are 8.1 notes, and we are going to do example 4. So your neighbor has decided to enlarge his garden. The garden is rectangular, so I'm going to draw myself a rectangular shape with a width of 6 feet and a length of 15 feet. It doesn't matter where you put these, either way. Okay, some people think of width in one place and length in the other. Doesn't matter. Now we're going to have this new garden, and it's going to be similar to the original one. So it's also going to be a rectangle, right? It's going to have 4 right angles, okay, and then the sides are going to be proportional if it's going to be similar. But it'll have a length of 35 feet instead of 15. Okay, so I'm going to draw a bigger rectangle. And this is now going to be 35 feet. Find the perimeter of the original garden and the enlarged garden. Okay, so I don't know the width of this one. Now I can easily find the perimeter of the original one. I have all sides that I need, right? And perimeter is just the distance around any figure. Okay, so the perimeter of the original is basically going to equal, well, I've got 2 sides that are the same that are 6. So you can do like 6 plus 6 or 2 times 6. And then 2 other sides that are opposite each other, those are also congruent. Those are 15 and 15. So you could do 15 plus 15 or 2 times 15. Okay, and when you add that all up, let's see, we get 30 plus 12, that's 42. Now we took some notes about perimeters of similar figures, so let's look at that. So the ratios of the perimeters is going to be equal to the scale factor. Okay, so I found the perimeter of one of them. Now I need to think about the scale factor. Okay, so let's see what the scale factor would be here. So I have 2 sides, so how about I go 35, so I'll do the big one over the small one. Okay, so my scale factor, or my K, would be 35 over 15. And I'll simplify that. I'll divide top and bottom here by 5. So I'll end up with 7/3. Okay, so that's my scale factor. And let's remember what our note said. The ratios of the perimeters equal the scale factor. All right, so I did big over small. So I'm going to do the ratios of the perimeters, the big one over the small one, and I'm going to set it equal to the scale factor. Okay, so let's see. So I'm going to take 7 over 3. That's the ratios of the perimeters. How about we just call this like the perimeter of the big one? And I know that the perimeter here is 42 feet. Okay, so maybe I should say little p. How about little p and big P? Okay, so big P goes on top, 42 feet goes on the bottom. Now I can solve that for P. Okay, so let's see. I'm going to have to go over here. But P times 3 is 3P. And 7 times 42 is 294. And now we'll divide both sides by 3. 98. So I get P is equal to 98. Okay, let's go back to this. So find the perimeter of the original garden and the enlarged garden. So the perimeter of the original was 42 feet. And the perimeter of this one, the new, larger one, is 98 feet. Now he can grow more food. Awesome. All right, let's move on to example 5. So in the diagram, I know that triangle PQT, again, is similar to triangle RST. And the area of triangle RST is 75 square meters. Find the area of triangle PQT. Well, I also think in our notes, we took some notes about areas. So the ratio of the areas is equal to the square of the scale factor. So not just the scale factor, we actually have to take that scale factor and we have to square it. Okay, so let's try and figure out what our scale factor is. All right, so how about, let's go ahead, I'll take the big one and put it over the small. So it's going to be 14 over 10. And I can reduce that. If I divide top and bottom by 2, I'll end up with 7 over 5. Okay, and remember the ratio of the areas is equal to the square of the scale factor. So basically that's like k squared. Okay? All right, so the ratio, of the areas. All right, well, let's see what we have here. We were given that the area of triangle RST is 75 square meters. So this triangle here is 75 square meters. And that's our smaller one, okay? So when I do the ratio of the areas, maybe I'll call this big A, okay, for the area of triangle PTQ. So when I do the ratio of the areas for the scale factor, I put the bigger one over the smaller one. So I'm going to do the same thing here. So I'm going to have the area of the big one over the area of the small one. And that's going to equal the square of our scale factor, which is 7 over 5. And then I have to square that. Okay, so the left-hand side can stay exactly the same. But before we do any math with this, right, we have to get this exponent, and we have to give it to both the numerator and the denominator of the fraction. So I have a fraction here, and it's raised to a power. That power needs to be given to both numerator and denominator. So this is really going to be 7 squared over 5 squared. Or in other words, let me come over here. A over 75 is equal to 49 over 25. Now, I wish I could simplify that a bit, but I can't. Okay, so I'm going to go ahead and have to cross multiply some big numbers. That's okay, I've got a calculator. 75 times 49 is 3,675. And then A times 25 is 25A. Solving for A, and remember A was the area of the larger triangle. And that's actually what I need to find, right? Find the area of triangle PQT. So divide everything here by 25, and I'm getting 147. So it's 147 meters squared, because originally we were in square meters. That's our units. Okay, we got one more problem, or one more example, I should say. So decide whether, and these are quadrilaterals here, GNMH and MLKH are similar, and explain your reasoning. Okay, so let's see, I'm going to use some colors. All right, so I've got this rectangle, GNMH. And I also have this other one, MLKH. And I have to figure out if they're similar. Now, it might be helpful if I redraw this yellow one so that it's like in the same orientation as this one, as the bigger one. So what I mean by that is maybe the longer side is horizontal and the shorter side is now vertical. Let's see here. So I could call this, if I just think of like rotating it 90 degrees this way, this would be M, this would be L, K, and H. Okay, and I know that L and K are right angles. Actually, I know that M and H are too. And I know this longer side on my yellow rectangle, which is 10. All right, so what we're going to do is figure out if they're similar, and we'll know that they're similar if the corresponding side lengths are proportional. So that's what we're going to check, that corresponding side lengths are proportional. And now that I've set it up so that they're in the same orientation, it's probably going to be pretty easy to figure out. So this is my yellow one. So I'm basically going to put the bigger one over the smaller one. Again, that's just what I'm doing right now. It doesn't always have to be like that. But I'm going to set up a proportion where I do GNMH over MLKH. And then I set it equal to another proportion set up where the bigger triangle's over the smaller one. Okay, so we're going to use some corresponding sides. So I've got 25 and 10. And then it looks like, see, this is interesting because I would have gotten confused had I been looking at that one, right? It looks like 10 and 4 are corresponding sides. Okay, so let's see if this actually, if these are equal. Well, this is going to give me 100, and so is that. Okay, so I know that my sides, or corresponding sides, are proportional. And in addition to that, let's see my notes. Corresponding angles should be congruent. And they are, right? They are all 90 degrees. And all corresponding angles are congruent. Therefore, GNMH is similar to MLKH.